All right. Hello, everybody, and welcome to the most wonderful time of the year. It is Advent of Code again. Time flies. It kind of feels like December was just 12 months ago. I don't know. It does feel shorter than that, at least for me. It's been a busy year. Lots of time, but I'm so glad that we're back and we get to puzzle a little bit more with all the wonderful puzzles that we get from Advent of Code. I already see that there's a whole bunch of you in chat, which is very exciting. Thanks to everyone who's already said hello. It's very, very nice to have all of you tune in again and join us for another round of puzzling. It's going to be a good time. Since Advent of Code this year is slightly shortened, you may have noticed that there will only be 12 puzzles. Our streams are also slightly shorter, so we will be streaming for the first 5 days. But that's perfect. It's a week. It's a week of coding, Monday through Friday. We'll still have wonderful guests, so we'll keep the tradition going. Hopefully, we'll see some cool visualization, some cool approaches to how you can do things in Kotlin, and hopefully, we'll learn something about the problems, how to be more effective with Kotlin. We'll maybe see it used in slightly more unconventional ways. The world is ours. We'll see how it goes. It's very exciting to see people in the chat saying that it's their first day of programming in Kotlin, or that they're learning Kotlin through Advent of Code, which I think is one of the greatest things that you can do with Advent of Code. Learning something new, trying something new. Yeah. So, of course, as usual, it's not just me looking at the camera here. There's actually a whole campaign that we have going on from JetBrains to support you in your Advent of Code journey. Actually, let me pop down here in the... I'll pop in the top corner up here. Again, thank you everybody who's joining. Very, very excited. I can also already see the first discussions of the first puzzle here coming up, which is going to be a good time. But yes, we of course have the Advent of Code in Kotlin campaign that we have currently running. There's a blog post that illustrates everything that you need to know. I've linked that in the chats that you can find both on YouTube, and we are also streaming in parallel on Twitch, just in case. If you are tuning in there, make sure you also send us a wave or something in chat. We can also see that part. But yeah, like I said, we're doing live streams for the first 5 days, which hopefully give you some interesting insights into how to solve some of these problems in Kotlin, or how Kotlin can also shine in these contexts. And you'll also learn a little bit more about Kotlin's ecosystem. If you haven't yet, make sure that you join the Kotlin Lang Slack as well, which is also linked here, where we have a wonderfully supportive community that talks about their solutions for the individual days, and where even if you don't have a solution yet, you can ask for help without spoilers. You can do some discussions and so on. And you can also find links to the live streams here, of course. The live streams are on our YouTube channel, so if you haven't yet, make sure you hit those notify me buttons for the upcoming days as well, to make sure you don't miss them, especially since one of them, day 3, will be slightly later. We also, of course, have leaderboards. While there's no public leaderboard anymore, we still have a little bit of a competition going on for the Kotlin community, so you can join one of those 3 leaderboards that we have. Please leave some space for other people as well. And you can see how you hold up against some other folks, including legends like Kotlin and Coroutine's creator Roman Yelizarov, which is very, very exciting. And of course, we have a couple of other interesting resources linked here as well, such as the GitHub template, which is a pre-made structure that you can use if you want to set up your Advent of Code project in a way that's really conducive to just solving the problems. Now, the other very cool part is that we still have a couple of presents to give away because it is Advent time, right? So make sure you also read the instructions in the blog post. Make sure you tag your public repositories using the AOC 2025 in Kotlin topic, and you will have the chance to win some wonderful prizes. Let's take a look here. There's a question on if you are in one of the last year's leaderboards, does it still remain for this year? The leaderboard does remain, but for this year, we are considering the leaderboards that are linked here. So these are 3 new ones. They are not the same ones. I can already see a lot of discussions, so I think it's really time to already jump in and maybe take a look at the problem. But I don't like doing this kind of stuff alone, so instead, I'm gonna bring on my first guest here for day 1. None other than Marton Braun. Hey, Marton, how are you?
Hey, thanks for having me on this. I'm doing great. It's so nice to be back to doing puzzles. It's nice seeing you because we've been really busy, and this is the first time that we're meeting somewhere in like a month or so.
Yeah,
even virtually.
It's been a wild couple of weeks, but yeah, it's so good to be back. Yeah, you've been doing Advent of Code for quite a while. I mean, you've been on the show for a while, and you've been doing it before as well, right?
Yes, I don't know how long actually, but it's been a couple of years. And when I first discovered it, I went back and tried doing previous puzzles at some point. I don't usually complete everything, certainly not on time, but I did give it a pretty decent go in recent years.
Oh yeah, I mean, I certainly don't complete all of them either, but you know, if there is an opportunity to give some folks a little bit of a run for their money, or you know, to crank up the heat a little bit, I do just like the ritual of well, first of all, solving the puzzles for myself. But then there's also that tiny little competitive thing as well, of just raw sharing stuff, which is always yeah, it's a good time. There typically is. I'm very curious again, if we're actually taking a look here. We can see that this is just 12 puzzles coming up. I'm very curious about the difficulty curve of these puzzles, because I have no idea. I'm assuming it will be quite condensed. Let's see if we can keep our head above water for the first 5 days. How'd you feel about today's puzzle, just on like a scoped out like perspective, before we even talk about what the puzzle was?
Yeah, I mean, I'm sure you'll make it to day 5. For today, I was very happy with the first part. I woke up early and I realized that it's Advent of Code, so I might as well just get up and get to it, right? I had like an hour left until my alarm, but that's fine. Let's just do it. And I was very happy to jump into the first one. I solved it. It was fantastic. Another star, all that. And then I spent like half an hour on the second part.
Mm-hmm.
It was too early. I got stuck in trying to solve it one way, and I just needed to reset and do it completely differently because I was down like the debugging rabbit hole. So part 2, kind of tricky, but it's fine. It was a decent first day.
Yeah, this stuff happens from time to time. That just happens. But yeah, so let's actually take a brief look here. I'm already spotting some people mentioning, well, maybe an off by 1 error. Part 2 was kind of messed up, or I messed up at some parts. Okay, well, let's take a look here, and let's maybe take a look at the actual problem description. Let me just first of all figure out a good place for us to be. I think this is fine, and then we'll just zoom this in a little bit. Which is also, by the way, a great point to reiterate that we're very proud sponsors of Advent of Code, as we can see right here in the sidebar. We're very excited that there is this initiative to give people puzzles that they can use to learn a new language, to deepen their knowledge of a language that they might already be writing, or to just try something and have fun and take a slightly different approach, build a visualization. Who knows? All right. Well, I wouldn't want to miss the tradition. So for the reading, I can already see it. There's a hat. I love that. That's a good look on you, man.
Thank you.
It's
I came prepared this time.
That's very good. I typically do have the emergency hat with me. It is just kind of difficult to transport that over TCP/IP.
Right. It's a year when we don't get to do this in person.
Yeah.
For once, schedule and everything.
Bit of a bummer.
It's a shame.
We'll figure something out for next time, though, I'm sure. Okay. Well, we begin our journey of Advent of Code 2025 with day 1. Secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains, due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. The rotation starts with an L or R, which indicates the rotation should be to the left towards the lower numbers or to the right towards higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So, if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19. After that, a rotation of L19 would cause it to point at 0. Because the dial is a circle, turning the dial left from 0, 1 click, makes it point at 99. Similarly, turning the dial right from 99, 1 click, makes it point at 0. So if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 could cause it to point at 0. The dial starts by pointing at 50. You could follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document contained the following rotations: L68, L30, R48, L5, R60, L55, L1, L99, R14, L82. Following these rotations would cause the dial to move as follows. It starts by pointing at 50. It's rotated L68 to point at 82, L30 to point at 52, R48 to point at 0, then L5 to point at 95, R60 to 55, L55 to 0, 1 to 99, 99 to 0, R14 to 14, and then finally L82 to 32. Because the dial points at 0 a total of 3 times during this process, the password in this example is 3. Analyze the rotations in your attached document. What's the actual password to open the door? And of course, we can take a brief look at the actual puzzle input, which is slightly longer than this list. It is a good chunk of rotations here. First of all, in case you don't know what project management is, you can click the helpful link. Unfortunately, unfortunately, I don't think it's gonna help you with the problem. Also, as I typically know, the Advent of Code community, this is the first time that anybody has read this text in full. Typically, people start reading like somewhere here diagonally or something. Martin, what were your thoughts when you saw
now
this?
that we actually read the text, can I just highlight the highlighted click word that's around the top of your screen? We'll get back to that in the second part. Otherwise, I was thinking it's fairly straightforward. I mean, it's first day, first part.
Yeah.
So we start from 50, and we're gonna increase that and decrease it, and we need to make sure that it circles around at 0, and I guess at 100, so that we don't overflow the range that we're working in. So I was like, this is gonna be something with remainders, modulos, something like that.
Sounds about right. And then at some point we should probably also count the actual zeros. All right.
Yes.
Okay, very good. Well, did you solve it? Do you have a solution for us?
I do.
Oh, very good.
Let's take a look.
Yeah, let me pull up your screen here. There we go.
Okay. And I think, yeah, that's a good layout. So here's the file that I started with. So this is what I actually wrote at like 7 a.m. today. So maybe I can just zoom in a bit more. Yep. So I essentially I have my input, which is everything just as a list of strings. So I'm using the M per starter project, which helpfully does a read input, which just reads all the lines. I think I modified this because it was a bit too smart with trimming or something, and I had a problem with that. So I just reduced it to read lines. And what I did for part 1 is we start from 50. We have no zeros at the start, and then we're just gonna go through and do all the rotations, right? And I did a very minimal way of deciding if we're going left or right. So I'm just gonna check if the first character is L or not, and that's gonna tell me if it's left or right, because we know that the input is very regular. And if we're going down, I'm gonna drop that first L, I'm gonna convert to int, subtract that from what I currently have on the dial, and then I did mod 100, and I hoped that this is the correct operation. I mean, the interesting part here, right, is that we do have two ways of doing this. So we have mod, which is not the operator. This is something different. And we have rem, which is the operator function. So this is what you get with the percentage sign.
Yep.
And in this case, it doesn't actually matter which one you end up with. I think. I'm pretty sure. Because with this, which gives you the remainder, it will always be a positive number, right? It's always the absolute value. I'm actually not sure which way around this is.
So I think it's the other way around, because I think this is the tricky part. We have both mod and rem, and mod is the one that gives you positive numbers, so that's what gives you a 95. And the other one just gives you a -5.
Yes. Oops.
Indeed, the question here is coming up. People, we're learning something new, and it's covering my face. Kotlin has both modular and remainder, and indeed,
yes,
the percentage sign is
the remainder.
The remainder, which is not what we want here.
Yes. So I believe it works for the solution, at least certainly for this part. Because it doesn't actually matter what all the precise numbers are. All you need is to check when you end up on a 0, right?
Yeah.
So it happens to work, but if you want to keep track of the actual numbers, you should probably go for mod instead of just a remainder. So that's the first thing that we learned. And then, so from here, it's looping through, it's doing all these operations. After each step, I check if it's at a 0, I count to 0, and I return that. And I have a clean version of my solutions, which is essentially the same thing. So all I did here is replace that zeros variable with a count.
Oh, very nice.
Very functional, very functional. And that's it. And I still have remainders here, which works fine.
I think you do kind of need to explain the count function here a little bit, because it's maybe not immediately obvious.
So what count does is it goes through our list of inputs and it runs this lambda for each element in order. And finally, if we return true from it, it counts the given element, and otherwise it doesn't. So it basically maps each element into a Boolean and counts how many truths we have returned.
Yeah.
It's the only way where I could put in some kind of interesting usage of the standard library today, because it's really just it's really just going up and down with numbers.
Oh, that's that's already a great way of dealing with it. Let's actually, if we compare this to my code, I don't think we'll see any big surprises here. Let me just switch this scene over again here. Unsurprisingly, my part 1 starts at 50 with 0 zeros.
Can you open the project panel?
Yes, I sure can. Let me.
Thank you.
Very, very good point. There we go. Okay. So it starts at 50. I do a little bit of input pre-processing using my patented parse input function. All that does is it takes the file at the given file name, which I have decided we're going futuristic. We're using modern functionality from the JDK, so no longer file but path instead. Figured why not? We still have extension functions like read lines on there. And we just pull out the first character and the amount as an integer, so that just makes it a little nicer to work with. And then I just used the for loop, but I used it together with the destructuring syntax that we have in Kotlin. So I say for each input, I have a direction and I have an amount. And, well, my new position is is either the regular amount or the negative amount, depending on whether we're going left or right. Then we mod the entire thing to make sure we actually go over. And if we do end up on a 0, we return that. So kind of the same approach. I did not do a particularly functional approach for part 1, but I do have something slightly elegant for part 2. But yeah,
that's very sensible. I have a single optimization for you. You can do minus amount with a unary minus instead of a multiplication.
Yes, I can, and I considered this, but I was like, I actually figured if I do this, I somehow considered it slightly less readable, because I wanted it to somehow be like just a small minus. I don't know. It was a conscious choice, but it's not one that I feel particularly strongly about. Maybe it saves a quarter of a cycle. Who knows?
I hope not.
I also hope.
I hope this is the exact same at the bytecode level.
But yeah, of course, apart from this, we do have a couple of mutable variables in here. Not particularly, it doesn't particularly matter because it's they're all very local. So I think this is perfectly fine, and I think the size of the function does not really lend itself to too many gymnastics here.
Yeah, I was gonna say we learned this last year, or you did with someone, right? That like local variables, small scope, mutability is fine. There was a lesson like this last year.
Yeah, exactly. If you want to find out where that was, you can go through all the 12 live streams that we have from last year that are on the Kotlin YouTube channel. I can't tell you which exact one it was, but they're all worth watching because they all typically come with their own gimmick, and they certainly all come with their own guest who typically have something interesting to say. Yeah, look at this. I found at least one ally here who also does not like -var name and would prefer an explicit multiplication. So that's very good. Okay. Ooh, there he goes.
Sorry, I am lost. I'll be right back.
That's perfectly fine. Anything else that's worth discussing on part 1, or are we moving straight on? I'll let him reboot here or I'll let him fix the setup for a second. In the meantime, I am just going to pull up our second part. By the way, we can of course also we can run this once just so that we have an idea of how long this runs. It is very brief, and the actual solution here is 10:55. So that matches what we had as the actual puzzle answer. So yeah, hopefully nothing too tricky so far. Yeah, minus video. That's yeah. very good comment.
I have something strange happening with my charging setup, so we may lose that again. I'm sorry.
These things, they happen. That's the we'll put some Christmas magic on, and that'll fix it. Yep. Yes, please do remember that the answers are not the same for everyone. Yes, please don't just copy my homework. I would encourage you to provide your own solution and run it on your machine. But it is indeed the correct solution for my test set, and I do indeed even have a suite of tests that makes sure that I didn't actually mess things up.
That is very professional. I do assertions. Well, I do check calls in my main function. I should start testing these.
This is by the way a very good reminder that if you are using assertion functions, you need to run with -EA, otherwise those will just not be executed. So everything will look great, but might not actually be. Okay, very good. Is there still anything left worth discussing or showing off for part 1, or are we moving straight on?
So one more note for folding. I think someone mentioned the fold operator in chat, and I was thinking of fold, but fold is easiest to use on a single value, and you need to keep track of both the dial and the zeros. So I could fold on the dial, but then I would have a mutable zeros variable. So I didn't feel like I can easily and conveniently make it work. It's very easy to work fold into this, but it will only keep track of one of your things, or you need to do a pair that you keep destructuring or something like that.
You need to have some sort of weird state container who would do that. Well,
yes.
We'll see about that in the near future. There is one quick point. Yeah, sorry, go ahead.
So the other question is, do you want to see a visualization for part 1? Or do we just want to do that?
I'm sorry, I did not. When there's an option for that, absolutely, we're doing that. I'm putting your screen back on here. Whoop.
Yep. You said you have a quick something. Sorry.
Oh no, there was just a quick point, which was that someone in chat would like to, I think, have a brief discussion of mod and rem and which one the percentage operator is, just to kind of bring that one back up, even though I think we just had that a moment ago. But just to
percentage is rem. We're gonna double check this. Percentage is rem.
So
mod
yes,
also exists.
And I think you kind of flexed something quite cool here. But again, you can just if you have the percentage operator, you can command click on it, and then it will send you to the implementation, which is really great. So that's a good way of checking this. Just click. It's a good instinct in Kotlin on most things. If you're wondering how does the iteration work with your in, or how does the destructuring work, well, you can command click parentheses. You can command click like operators. There's all kinds of things you can command click, and IntelliJ is gonna send you right where these things are coming from, which is useful. Okay,
I see what people are getting at with this running fold thing. Actually, that does give us what I wanted to do.
Well,
so you can do
let you whip
something
it up.
like so you can do something like this, and I think I'm off on just parentheses at this point, where the running fold will produce all the intermediate values. So it gives you a list of ints as a result.
Okay.
Right, so you throw in 50, you get the current dial value here. You can use that. And, oh, I guess I lost something here. So it should have been like dial plus, dial minus, other way around. Something like this. I'm not going to check if this actually works on my current input. But basically, you could, it is 0. So this would produce all the intermediate dial values.
Mm-hmm.
Return it in the list, and then you can check how many zeros you've seen, which is actually very nice.
So effectively, this is an approach of let's just materialize all dial positions, and then let's count which ones are 0.
Yes.
Which is also a cool approach. Needs a little more memory though.
Sure.
Just a tad.
Yeah. Okay.
I was promised a visualization.
Yes.
Eagerly...
Sorry. I was sidetracked by chat. Thank you, chat. So visuals. As I mentioned, I have an Amper project here. So it was roughly 3 lines of code to add compose to it.
This is very good.
So what I said was compose enable true, and I wanted compose UI and compose desktop. I'm actually not sure if I need both of these. One of these might be added by default even. So that's what I did for compose setup. And then to create a window, it's compose application, you create a window, and then you write all your compose code in there. And it's not particularly nice compose code, but it does the job. Let me run it first. And then we can actually... so it does come with hot reload built in by default. No configuration. And if we open this up, do we get this?
That's Is that a subtle metal texture that I spot on the actual dial?
It is.
Incredible.
Of course it is.
Incredible.
You know where that's from?
I might have an idea.
It is from right here.
Very
from
good.
One of Sinazamaki's samples. I think there's even another page we can hop to. So yes, it's brushed metal UI in Jetpack Compose. And of course, all of this works the exact same in Compose Multiplatform. So I basically just went to this page, I copied the metal button, I removed some bits from it, and oops, spoilers. And yeah, that gives us this.
That's incredible.
And I mean, all of this is just compose code. So for example, those little tick marks are, if we go here to the dial, I hand wrote all of this, no AI this time because it's advent of code, right? So I did all the math, I did sine and cosine, and I translated all of them from the center to the correct place and rotated them a bit. And all that, and basically you have pipe symbol and number, or pipe symbol and nothing, and that's what draws all these ticks.
Oh, okay. That's incredible.
Yep. And again, you can play with all of this because it's compose hot reload. So if you wanted to see if larger numbers work better, you can find wherever the numbers are, and you can go like 40 SP, and it will compile a bit. First one's probably a bit slower, but now we have larger numbers, right?
Yeah.
And then we revert to 32, and it compiles a little bit. Bam, 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 bam. Did I not save? Oh no, did I get it stuck already? What happened?
There you go.
Right, now it works. I feel like we might have a bug where we can't go back to the same exact spot. I broke something slightly.
Always learning something new.
Surely if I break it completely and then go back, we'll get the correct value. I tripped it up somehow.
I like
none
I like
of this,
something
obviously.
I like something in the 40 range better anyway, to be honest.
Okay, manual reload definitely works.
That's good.
So yeah, we have that. Oh, and of course, like we are drawing all the numbers from 0 to 99 here. We just have like a small thing to determine if something is a primary one, and then either show the number or not, and all that. So how do we run part 1 on this? Well, if we scroll up all the way here, we'll find a button listener at some point. And I do have to move this out of the way. And it looks something like this. So I read my test input, because it's a lot smaller, obviously. And then we just loop through. And I have a target here, which is compose state. Starts from 50. And all I need to do is keep updating my target. And wait. And the dial handles everything. So
Just
we can run part 1.
Oh,
and it just goes through all the paces.
oh, you love to see
There's
it.
a 0.
I love the little 0 visualization. That was very cute.
There's another one.
Oh, that was a...
And now we go all around with 99.
Oh.
There's another 0. And I think that's the end of it.
Mesmerizing.
That's part 1.
What
And now we can reset to 50.
How excellent is this? How excellent is this? I love it. I'm semi speechless. No, but this is so cool. It's also I feel like you kind of you showed off so much stuff so quickly. It's really impressive, and it's worth reiterating. So first of all, you showed
yes,
off...
all of this will be on my GitHub for the record. So it's already pushed to GitHub, so you can find the code there.
Very nice.
But
nice.
we can go into some details, yes.
Well, I mean, first of all, what I really loved is you were building this entire project with Amper, right? Which means there's no Gradle involved anywhere here. What you showed us, those like 10 lines of code here, that was the entirety of the build configuration, which is already really neat. We saw that we have the integration with hot reload, right? So you can make changes quite quickly, and you can see them update live while the application is running. And also, we see that with Compose multi-platform, we can take all of this wonderful code that already exists, or that folks like Sina Samaki have already built for Compose, and that they do work exactly the same way on the desktop target as well, which is just, it's really, really cool. Maya adds a good point. A couple of clicking sounds would be quite delightful. That will be the next step. I don't even know if we would have the infrastructure to stream it through the stream at the moment, even if there were some clicking sounds.
I was asked if I wanted to share my sound when I did the screen share, so probably, but I will admit I did not do the clicking sounds. Although I did consider having like a bell sound on zeros, because that would be quite fun. You can see hot reload in action here if I play with the like alpha of the circle in the middle, which is just a black circle. Right?
Yeah.
Like this is exactly how I built the entire thing, just iterating on it bit by bit on the theming. Someone asked a very important question in the chat, which is, can you resize the window? I mean, I can. Look at that. Isn't that wonderful?
Yeah, that's incredible.
It resizes just fine.
Yeah. Do it. That's excellent. That's excellent.
Don't worry about it.
Yeah.
So yes, obviously everything is hard coded, but what are you gonna do when you also need to do work on the same day?
Yeah. All within the spec. All within what's required. I'll be honest with you, this is much more entertaining. Yeah, no, this is much more entertaining than if it just looked great. This is. I do love the excellent. It does have an egg-like nature to it. It would seem
Yeah.
very, very good.
So yeah, I think that's most of the code looked through. I guess we didn't really look at the dial part, but what I was doing is I was playing with this target value from the algorithm side, so from the click handler side, and what I do then is from the target I calculate the rotation that we need, which is, I mean, you divide by 100 to get the ratio, where you're going in the circle, and then rotation works with degrees, so you multiply by 360, and that's essentially it. I do let target run to any number here, so I don't actually do the remainder or anything like that anymore. It just runs to any positive or negative number, and to do the counting part, I just check if it's divisible by 100 at the given point. I'm not sure how I solved here. Yes, I was doing a lot of things at the same time here. I was trying to count in different places, but now it's the actual dial that does the counting. So after it animates, it checks if it's on 0, and then it triggers a callback so that we do the counting.
It's probably also good that you don't do any modulo stuff on the animation, because you might do like 2 entire loops, right? On like a single rotation in theory.
Yes, and you would be, so otherwise you would be rotating. Well, it would always go. It wouldn't always go the right way.
Yeah.
Right.
Like you'd end up in the right place, but like it would visually not look like a rotation of 200 clicks.
Yes, so rotating 99 to the right would certainly just do like a rotation of 1.
Yeah.
Oh, and actually that's the point I wanted to make at the beginning of part 1, is that rotating right and left is kind of tricky in terms of terminology, because I did imagine this kind of dial the entire time.
Mm-hmm.
And if you look at it from here and you say rotate left, that should go down according to the puzzle input, right?
Yeah.
So left counts down, but for me, rotating left feels like counterclockwise rotation, which would go up. So that's something you can also trip up on if you're thinking of the dial too much and you have the wrong concept of left-right rotations.
Yeah, that's very true. It was one of the things I just kind of like locked myself into. Like in the beginning, I was like, let's see what they say on what is R and what is L.
Yeah.
Okay. Yeah, very nice. Awesome stuff. Well, anything else here, or are we moving on to part 2?
Yeah, I think that's all. We
Very
can go to part 2.
Let's see what part 2 has in store for us.
Oh, let's see.
I'm gonna pop this back on here, and we will move ourselves here. Why not? This seems good. Okay. Well, we can't forget. Hats go back on. I love the hat enthusiasm in chat as well. It is an appreciated tradition. So let's dive right into part 2. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman, well, you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method OX434C 49434B until further notice. You remember from the training seminar that method OX434C 49434B means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Following the same rotations as in the above example, the dial points at 0 a few extra times during its rotation. We start by pointing at 50, then we rotate L68 to point at 82, but we pass over the 0 once while doing this rotation. Then it's rotated to point at 52 with R48. It points at 0 with L5 at 95, with R60 at 55. During that rotation, it once again points at 0. L55 to point at 0, then L1 to 99, L99 to 0, R40 to 14, and L82 to point at 32 with another rotation across the 0. In this example, the dial points at 0 3 times at the end of a rotation, plus 3 more times during a rotation. So, in this example, the new password would be 6. Be careful. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Using password method OX434C49434B. What is the password to open the door? Okay. So, thoughts?
Yep. So the problem itself seems to be self-explanatory based on what we had so far. Instead of just passing 0 by, we also need to notice when we pass 0 and count it, right? Let's talk a bit about the text first, I think. So yes, there is the password method 0x and so on and so forth, which does spell out click in ASCII, as Chet already noted.
Oh, excellent.
So it's CLICK. I found this out during the stream as you were reading the first part. I realized this must be an Easter egg, so I did the conversion, and sure enough, it does spell out click. Someone also noted it has an Easter egg on hover, and I don't know what they mean because I didn't find an Easter egg. I tried hovering everything.
There is typically one word that does have an Easter egg on it. Oh, there it is. You should have seen the chaos when the elves overflowed their 32-bit password method counter. There we go. Very good. Excellent.
Okay.
Excellent.
Yes, so yeah, we just need to count the zeros. With all of them this time. So what I was thinking here initially is that I can just do the math on this and realize if I'm gonna loop around and just count the extra zeros.
That was your initial approach?
I definitely didn't read the line, which starts with "be careful."
Huh.
So I was a good 10 to 15 minutes in when I went back and read the "be careful" line, and that's when I realized that like a single if-else statement will definitely not do it.
Yeah.
Like checking before I apply the remainder.
Yeah, because like if you're actually doing like 50 rotations while you're hitting the 0 50 times, yeah.
Yeah. And then I tried doing all sorts of things. I think we can go to the code unless you have an initial thing as well.
Well,
how did you feel about part 2 after part 1? Yeah.
I looked at it and I was like, surely I can. I was like, there's probably a clever solution, but let's get to a solution first. So my initial thought was like, well, I can just simulate like every single click, like every single rotation, not just every single 0, but every single little turn. I'll repeat step 1 motions rather than doing large motions and doing some math.
This sounds pretty smart. Yes.
I do also love, by the way, the wait, what? I never saw the "be careful" line, which is that's peak advent of code. 100%, yeah. We're also eager to get to the code, so let's actually do that. Code.
Yeah. So my initial version here is just a broken implementation that doesn't work, but it gets kind of close. So my answer was in the 6,000 range, and I shot all over that range in like 5 different attempts. None of them were correct. They do work for the test input, obviously. And I was doing things like keeping track if my previous value was 0 and if I was starting my rotation from a 0. I was keeping track of the sign of the dial, and I was like, if the sign changes as I rotate, then I've passed the 0. So this will be useful. So I was doing all sorts of things. Sign, by the way, is just a built-in property that gives you -1, 1, or 0, so that you can figure out if it's a positive number or not. I obviously have a bunch of print line debugging here. At some point I was doing the while loops of if we went below 0 or above 100, we're just gonna 100 by 100 get back to the normal range and do counting on the way. And none of this works. It's off by some amount. I have no idea. So it took me
Yeah.
it took me like 20 minutes of fiddling with this, and it went nowhere. And then I realized I could just do it click by click. And here's what click by click looks like. And now I'm wondering if this could be a running fold or something. But it's very straightforward, very imperative code. We start from 50. We have no zeros. We have a delta at each step, either -1 or 1, based on the direction. And then we just repeat as many times as that step said. We click the dial. And if we're at a 0 at any point, we count the zeros.
Yeah.
Extremely straightforward solution. Works like a charm, turns out.
Very good. No, excellent. Very good. What does that look like in simulation?
So visualizing this, the code is essentially the same. So I do go fast mode through here, and don't ask about that. It's to make the zero detection thing change state at a different time than usual, just so that it looks better.
Sure.
But otherwise, yes, it has the delta. We repeat as many times as we have to, and we're still just updating that mutable state and then giving the animation some time. I decrease this to 100 milliseconds so that obviously we don't have to wait like several seconds for each click. And if we run this again with hot reload, and I drag the window back to where it should be, there we go. We can run part 2, and it's gonna go click, click, click. And it will count zeros whenever it passes them.
Very good.
Right? And it's still the dial doing the actual counting.
Proper safe implementation.
Yes.
You love to see it. Oh, okay.
I'll give you one fun detail here, which is that for this counting to work, I did need to mess with coroutines a little. So if we go to the dial where it's doing its rotation thing, somewhere around here, and I'll try to zoom out a bit, just not too much. So we're doing this in the launched effect, which launches a coroutine, and animate2 is a suspending function, which will be within that function call until the animation is done.
Yeah.
And if you do this for an animation delay of 100, as I was doing, and then you have 100 millisecond delays between the times when you update the target, every time this will get cancelled, because target updating will cause this function to recompose. It will launch a new launched effect, which will try to animate for 100 milliseconds, so it will never be quite done by like a couple milliseconds. So this will always get cancelled. If you do the counting after that point, you're gonna miss your zeros. So that's why this is wrapped in a non-cancelable context, because I want to make sure that on every invocation, this actually runs to completion and it can do an on count. Wait, I should be doing a try finally. That's also an option actually. I could be doing this in just a finally block.
Look at that.
That would also make sense. And of course, we can play with the ratio of delays. So this button click has 2 delays, so it animates for 80 milliseconds and it waits for 100 between updates of the target. But like we can play with this. We can have like an instant animation. We can have like a tween 0, and we can save that. Wait for a hot reload. We can reset, and now it's gonna go click, 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 and it still counts the zeros because of the non-cancelable thing. Wait, no, it missed one. I broke something.
Fair enough. In the visualization code, that's okay. Maya says that the animations might need an ease in and ease out so that it really feels like some safe cracker is trying to turn that dial.
Yes, it's more difficult with this step-by-step thing, right? So it's a tween animation with whatever the default spec is. And I think that works nicely when you have the 2-second rotations in part 1.
Yeah.
But here, because I'm doing a lot of small rotations, you can't really see any of the dynamics of it. So the really precise way of doing this would be to still just run the large animations for each turn. Do the math of when on that easing curve it's gonna hit 0, and then you increment the count.
Yeah. There's
I'm not gonna do that.
Yeah, exactly. There's an infinite amount of complexity that you can have if you'd really want it.
Yes.
Not sure.
I mean, there might be a Compose API that can tell you. I'm really not sure, but maybe you can ask the easing curve. Like, you can do the math of, we're going from 20 to 70. So at 40% of the animation, I want to get the timing value for that. I'm sure Compose can somehow give you that if you have to have your easing in your hand.
If you know that API, let us know in chat.
So what's the default easing? So you grab an easing value, and then so you can just transform a fraction. So you could do the math of which fraction you need. You can transform that manually using the same easing object. Then you'll know how that maps to time, and you could do a second coroutine with that delay and increment the counter. Sorry, I meant 20 to 70 going through 0. Yes, so I think that's 40% of the way for the 0.
Fair enough. Well, so
you could probably just monitor the rotation angle is an idea in chat. I tried. One of my implementations was just checking if the rotation angle is within 2 degrees of 0. I had that as well. It works really well if you always stop. If you do quickly spinning things, obviously you just might not have a frame there, or you might get your coroutine cancelled if you didn't wrap it with non-cancelable things. So it gets tricky and kind of annoying.
It sounds like it could open the door to new speedrunning strategies. Where people skip just entire counts while still going from one place to the other on the dial. I don't know how that will be useful, but still very much so. I do still have a solution to present myself here as well, so I'm gonna.
Yes, please. Do you have a smart solution this time?
I kind of do. I think I do, anyways. Let me put us. Hold on. Let me put us back over in our little corner here. There we go. So first of all, I had the direct approach as well, because I thought, well, let's get to a solution, and you will see this looks very, very similar to what you had and also what I had beforehand. This time the amount just gets turned into a repeat, and we just update the position either by -1 or +1. We make sure that we stay within the mod, and if the position is 0, we increment the number of zeros. That's it. That's not particularly interesting. But then I figured, probably I can make a couple of educated guesses, or, well, I could make a couple of educated calculations that help me avoid this. So here is my initial implementation that is a little bit faster, and I'll walk you through it. So first of all, we're staying with kind of an imperative programming style here. We still start with position 50, 0 count 0, and then we go through each element. So first of all, I just need to make sure that I keep the start position somewhere. This will become relevant later. First of all, one of the things that I thought was important was, or that was easy to extract, was if I'm doing entire rotations. So if I'm doing rotations that are the length of 100, those just give me 1 0 for free, like always.
Which is a thing we need to be careful about once
Yes.
again. So this is the be careful sentence from the text.
Yes, exactly. So if I have like an R400, then I know that I'm doing like 4 entire loops. So that's 4 zeros that I'm hitting. And we will just we'll just add this to our zeros count. And then I just have a slightly extracted math to make sure that I actually change the amount correctly based on direction. So this just uses the instead of going the entire way, right? Because now we're only interested in non-full rotations. So out of like 370, we're only interested in the 70-bit anymore. That's how much like we will shift within that last remaining rotation that we have. So we can update the position internally, first of all, because that will be like, obviously a full loop will not change the number, right? Like if you're on a 3, you rotate by 100, that means you're still on a 3. And if you're rotating by 103, that also means you're only interested in the remainder. Like you'll add 3 to the right to your position. Okay, and then here's something that's maybe like slightly tricky, which is that we need to kind of keep track of our modded position. So again, like the position in the within the range of 0 through 100, because this shift might still give us a negative value. Once again,
so you're letting position run out of range here temporarily, just for the middle of this section in your loop, right?
So what I'm doing here exactly. So what I'm doing here is I'm using the rem operator. I'm not using the mod operator because I specifically want like a left turn of 5 to be represented as like a -5, and I also want a -105 to be represented as a -5. But then I have my modded position, which is like actually the value that's back between 0 and 100. Now and then there's 2 cases that add more zeros. There's the case where we start on a non-zero and then we end on a 0. That means we need to add 1 more 0. If the start position had already been a 0, that means we would have done just if we go from 0 to 0, that's just a full loop. So we already counted this. We need to do this check of both positions. So start position not equal 0. Yeah.
And you don't want to count when you're just moving off of a 0, because you've already counted that when you arrive to it.
Exactly. Yes. Exactly. And then the other part is we are if we are changing the position, if the modded position and the position are different, then that means that we've kind of changed sign, right? Like we've gone from positive to negative, because otherwise the modulo operator would not have done anything.
Yes, which might just mean that we went from 98 to 105. So
yes,
that also is a sign change, which is why you don't want to use the actual sign property that I was trying to mess with.
Yes. So that's
because it might be a change of just positive out of range.
And it's important again to notice here that we still need this precondition of your start position can't be a 0. Because if you're already on a 0, then you're like going -1 feels like a sign change. Like your mod and those two values are going to be different. But factually, like intuitively, you understand that does not add another 0 because you're just clicking away from the 0. So, oh yeah. And also, by the way, make sure you don't accidentally double count, because there are cases that fulfill both of these properties at the same time, so it has to be an else if, which is yes, very very non-trivial. But this does get you the right solution, and I don't know, it's probably faster. I didn't benchmark it, but then I figured this was still. I figured this was kind of hard.
Sorry, crucially, at the end of the loop, you do update the position to the modded one again.
Yes, so then then we have a valid dial state again, effectively.
Yes.
Yeah. Yes, and then we return the zeros count. So yeah, a little bit of spicy stuff in here. I decided I also wanted to take a functional approach to the same thing, which looks like this, which looks like it's more code, but I think it's actually easier. So we'll walk through this again. This time, I really want to have a fold in there, and like
it does feel like a folding thing.
Yeah, and like Martin complained about beforehand, our state is kind of like it's a pair, right? It's a pair of the position and the zeros that we've seen so far. So I just created a dial state class. It has a position, it has zeros, and first of all, I just needed to do a little bit of pre-processing, because I didn't want to do that in the loop. I just convert all these this textual information of left and right to the actual minus and plus. And here I used a unary minus even. So yeah, this is just essentially now a list of -50, +20, -30, +115, whatever. Just makes the math a little easier. Okay, and then we just do we fold over our moves. First of all, we save ourselves the start position because we need that one. We still want to know how many full loops we did. That's just the absolute value of our change, because now they're signed. So now we need to convert them back to absolute, divided by 100, and this goes straight into our new accumulator for the zeros. So finally, we will just accumulate a big sum of new zeros, and we'll continue folding with that. But yeah, so the full loops go right in there. Then we once again calculate new position and modded position. And this time, instead of having some nested conditions, here I effectively just have the same conditions we had beforehand, with start position not equal 0, modded position equals 0. If that is the case, then we add 1 to our zeros. Otherwise, we add 0. And the same for the second part, which is we started on non-zero and we wrapped in one way or the other. Then we add 1. Otherwise, we add 0. Which means that at the end, all we do is we look at the modded, or all we return is the modded position, plus all the zeros that we've seen so far, plus all the full loops that we've seen, plus if we landed on a 0 in this turn, plus if we started on a non-zero and we changed our sign, we wrapped in either of the directions. Yes. And now we have no more mutable variables in here, and we don't even have any nested conditions. That part's maybe debatable, but yeah.
Yeah. And so you're replacing the zeros count plus operations with this if else 1 0
yes.
sort of setup. You're not double counting because why are you not double counting?
Oh, I'm not double counting because I just inlined this condition. So the condition that we had outside here beforehand is just inlined twice here.
Okay, you just have it and then you inverted the modded position part.
Yeah.
Yes. And then you still do have the mod operator and the remainder operation on the previous line, and I'll be quite honest, I forgot already which one will give you a positive or a negative value. So now it's scaring me that the amount might be negative and you're doing a remainder 100 on it.
Don't worry, I just use absolute value.
No, but on the next line.
This one?
Yes.
Oh, that's intentional.
So that's...
this will give you a negative value.
Okay, so I didn't know if it will and if it should.
Yes.
I didn't know either of these things at this point.
Yes. Of course, we're kind of deep in the weeds here. But, like, our new position, like, for that one, intuitively, you kind of want to keep the sign, right? Like, if you have a rotation that's minus 150, you want a minus 50 out of that. Because you want to still go in the right direction. You just kind of want to ignore all the full loops that you've done in the process.
Right.
And then for the actual value, like on which the dial sits, you just put the new position mod 100. So this one gives you always a value between 0 and 100. I have a hunch that probably you could get away with not even normalizing the positions at all. But that would probably require figuring out where all the zeros are, like counting every time you pass a multiple of 100. And then maybe you can avoid some of this, but I think you'll get a bunch of extra complexity in another place that might not be worth it. And this is like, I'm already at the border of what I can understand. So yeah. Bit of a spicier solution. Anybody in chat have an even more interesting approach for this? I do love that people love the fact that both rem and mod are being mixed here. This is, I think, that
is what I feel like as well.
Yeah, but I think it is probably the key learning, I think, of today's problem is not so much the actual like math. It's knowing that there is a difference between remainders and modulos, and if the result isn't the one you want, then you use the other function. I think is typically the approach. Yeah.
I am very happy that all my solutions only have remainders in them. So all I used was the operator, and I never have a mod mixed in with it.
That's a good move.
Which just helps keep track of things.
Sure. Yeah. No, it certainly does. Rem is evil. Percent equals mod when we're taught in school. I'll be honest with you. I've been trying to remember this. I don't even know if remainders of negatives ever came up for me in school. I don't remember.
It's kind of rare, and you address it when you need it. But it's always the other way. Like unless you get to actually coding something, I feel like in math it's always just bringing large numbers down into a valid range.
Mm-hmm.
It's very rare that go negative.
Yeah, what I do think is a good point is that people use percent and then they say mod, and then people say percent when they should say rem. I guess I don't even. Luckily the percentage sign has nothing to do with calculating 20% off in programming at any point. So that's already a win.
Yeah, I mean for a lot of usages, percentage sign is mod, but not all of them. Yeah,
and for positive values, you could not distinguish between the two anyways. So yeah. We have one more here, which is I normalize the begin-end values of the range that goes from current dial value to the new one and just counted the hundreds using clever math. Exactly. See, this is what I was positing. Exactly. Very cool. That would be interesting code to look at as well. Very, very nice. Maya asks a kind of nice meta question here. What do y'all think that Eric is trying to allude to with the initial puzzle? He often sets up future puzzles. Could we be doing more code breaking, perhaps? I do kind of... I mean, now that I've seen the dial, I do just kind of... I kind of love it. Can we see that again?
Oh, yeah.
We just...
I did, of course. Close it again.
I mean, there it is again.
Let's just run both parts. Let's just solve it.
That's gorgeous. Yeah, let's just solve it. Visually.
There could be a lot that you could do with this animation. You could scale it a bit when it's moving.
Yeah.
You could add some blur to it, probably.
Could put like a...
Actually, the time of the animation is fixed at the moment. So you could also...
Sorry. Someone wants to see the animation while you're squishing the window.
I think this is fine.
Fair enough. Fair enough.
No, I mean, luckily it restores when you unsquish it, so it's fine.
That's great. There might be a potential simplification for my code, apparently, by checking whether the start position is 0 or it's not in between 1 and 99, which I think effectively just expresses the same as having a skip over. Yeah, it's probably a more idiomatic way. That's nice. Oh yeah,
well,
yeah.
So what is in the text, by the way, is that we are not saving Christmas this time.
It's true. Christmas is fine.
Right?
Well, I don't know.
Because project management.
Yeah.
So what we're doing is actually decorating the North Pole. So hopefully we get to see something around that in the next puzzles. Maybe we'll be hunting for tree decorations. Something like that.
I'm
looking for a tree. Looking for trees.
Oh. I'm expecting some sort of like Maxwell Smart style, like just ever increasing layers of security until we get to like the button that says decorate or something.
Yeah, it could be.
Like an iris
maybe it is
scanner
just
type thing, or who knows?
Just a big heist movie.
Maybe the big Christmas heist. Yeah. I do like the hypothesis here from Jonathan as well. We're doing a break-in room, not an exit room. Yeah, project management works and adjusts well for unknowns, as everyone knows. Very good.
I just realized we should run this order for the real input.
Please.
I think it's gonna... I don't know what to do with the delays. Let's do something conservative. Let's try like 10 and 20.
The elves are using the frozen waterfall as their methodology. That would make sense. And we're gonna be here for a minute, huh?
Oh, we're definitely missing zeros now.
Well, you know. The last part you can just figure out by guessing. I don't know. It is going to be 4,412, at least in my input. Rotation instruction.
Oh, mine is above 6,000. So.
Oh, okay. Oh,
it should
very
take
good.
us a while.
Oh, so then we have a good way of filling the time all the way till tomorrow. Until the next puzzle comes out. Because the next puzzle does come out sooner rather than later, in only 10 hours and 40 minutes.
No, there is an ask to replace tweening with Spring. So let's just do that. I don't know why I did not run this with hot reload. But I'm just committing to relaunching now.
I'm expecting something bouncy.
And this is somewhat boring. In comparison. I mean, what we could do here is mess with this a little. So we could have Spring Damping. Medium bouncy. Stiffness low. And let's actually do hot reload this time so that we can adjust. Where was this? Bouncy.
That is bouncy. That's I would say not representative of how I think a safe dial works, but it is pretty cool.
Yeah, of course, reduce the delays. So we can do, I don't know, like 1 second delays or something.
Amazing. That's really cool. How long did it take you?
This is how a strange robot would solve it.
Have you seen those robots that can turn those dials for?
I assume they don't overshoot.
Yes, they certainly don't, but they do it with an impressive both speed and the accuracy. How long did it take you to build this visualization?
I have no idea. It's just fairly quick. I would say within an hour for sure. But I honestly don't know because I was hopping back and forth a lot.
That's pretty good though. That's pretty good.
I did initially have a much uglier dial, but then I was like, 15 minutes before the stream, I need to clean this up a bit because I didn't realize what real dials looked like. I did Google them earlier, but I didn't take a proper look. So I didn't have the differentiation between primaries and not. And so if you just go like all primary, well, first of all, it's too large. But I had, something like this, which is like fine.
Yeah,
but it doesn't have the same vibe to it.
It's not the vibe. It's true.
And of course it's all hard-coded things, so you would want to like change the radius so that it's, I don't know, like 360-ish or like 357 or something like that. Yeah, but this certainly doesn't look that much as a dial.
What I find an interesting point is that apparently here Aneroid says your dial is correct clockwise. I guess that makes sense. Yeah, no, that's fine.
Oh yeah, it is going the right way. I'm pretty confident about that part.
Yeah. I do, by the way, also love that someone here shouts out Kotlin notebooks to get an even better understanding of the data. Personally, I prefer the visualization of this, but if you're a fan of Kotlin notebooks, you should tune in one of these other upcoming days, because we are doing 5 days of Advent of Code streaming, and one of them will be Advent of Code. I'm not going to tell you which one. You're just gonna have to tune in and find out, because even if it's a non-notebooks day, we'll be sure to entertain you some other way. Martin, this was great. This was delightful. Thank you so much for preparing both the solutions and the visualizations. A really, really great way to start the greatest time of the year, the most wonderful time of the year with Advent of Code. Well, and of course, a big thank you to everybody who's joined today. Just to very briefly inform you once more here, we have, of course, careful, the screen is going to turn white. I flashbanged someone beforehand here. We have an entire campaign for the Advent of Code. If you haven't seen that yet, make sure you check it out. Most importantly, make sure you hit that notify me button for the upcoming streams. All of them that we have on the Kotlin YouTube channel, to make sure that you don't miss them. Join our leaderboards if you haven't yet. They there are cool prizes to win, even if you're not competing for first place. Just being on the leaderboard and having a couple of solutions publicly available makes you eligible to win some cool stuff. I'm actually wearing some of the previous Advent of Code in Kotlin swag right now. It's this T-shirt, for example. But there's also there's other stuff as well. We have our Advent of Code GitHub template that you can choose to try and work with. And of course, we also have all the previous years where we've done Advent of Code apparently since 2020. Oh my, we've done a lot. And we have all the streams here. We have the solutions in the video. We discuss some specific details there. There's always something new to learn. Yeah, so make sure you check that out. And most importantly, make sure you, well, first of all, come back in 10 hours and 34 minutes to solve the puzzle. And then 12 hours after that to join us for another stream. Martin, any predictions for tomorrow?
Well, I was expecting something with actual decorations, but now you have me convinced that maybe it's just gonna be the big decorate button at the end of a lot of cracking doors. But I think it's not gonna be another door at least. But it might be like a puzzle sort of situation.
What kind of what are you
riddle.
thinking? You thinking we're getting
Well, I hope you're gonna get a tree, like an actual tree structure somewhere in the first 5 days.
Okay.
That would be quite nice.
That would be
like,
good.
Assemble the Christmas tree. Yeah.
Okay. Yeah, like some sort of like graph style problem. I could see that. I just know there's gonna be a maze in there somewhere.
Yeah.
There's no way there's not. Unless last year's like 10 mazes in a row have like somehow spelled the end of mazes, which I doubt. Yeah, is it too early for a labyrinth yet? I don't think it is. We'll find out tomorrow. It's gonna be a good time. Thank you so much, Martin, for coming on. I appreciate it. This was a lot of fun.
Yeah, thank you. It's very nice being able to kick off this year's Advent of Code. Can I give shoutouts to 2 more things that we're doing? Because
Please.
It is December, so you think everyone would already be off on vacation and not doing anything. But we are doing our KMP Level Up campaign still. And if you hop over to YouTube, exactly, we have the live stream for that scheduled for this Wednesday. That's correct, right? Yes, it's on the 3rd. So you can turn on notifications just like that. And so we'll have a great chat about how to learn KMP. And we'll, of course, invite you to join the regularly scheduled Advent of Code stream right after we end that. And another thing that we're doing is a Reddit AMA. So an Ask Me Anything on Reddit with the entire Kotlin team. At least a lot of people from the Kotlin team, like dozens of different people.
Yep.
Which is going to be on the 11th of December. So that's next Thursday, if I'm doing my math right. So make sure that you tune in on Reddit and you can ask questions there and get any Kotlin question that you might have answered.
Exactly. Very cool. Awesome
I think
stuff.
that's all.
Hey, wonderful. Great. Then, from here, I'm going to go make myself another cup of tea and then probably slowly wind down so that I am energized for tomorrow. Thank you, Martin. Thank you, everybody who is tuned in today. And we, of course, hope to see you again tomorrow for another iteration of Advent of Code in Kotlin 2025 edition. Thank you so much for tuning in. See you tomorrow. Take care. Bye-bye.
Bye.